ideal weather. 70s, I could be a happy person. Okay. So I think this was the first example we skipped yesterday. Marla needs to find the height of a building. From a given point on the ground, she finds the angle of elevation. So let's stop. We've got a building. Trying to find the height of that. So that's my x that I'm trying to find. From a point on the ground, so the ground would be here. Angles of elevation, they go from a horizontal, so that would be the ground, up. So the angle we're referring to is right there. That angle is 74.2 degrees. She then walks back 35 feet. So she's standing here. She backs up 35 feet. From the second point, the angle of elevation. So again, elevation is from a horizontal up. Now that angle is 51.8 degrees. Find the height of the building. This is kind of like the example I did out of section 2.4 where I said, I'm not giving you any like it quite yet, but we will have them. This would be a right angle. How many right triangles are in this picture? Two. If we look at that red one, you don't have to necessarily redraw them, but it helps me sometimes just to see the pieces I have. That's 74.2. This is x. I don't know this side. Let's call it y for a minute. And then in the whole triangle, this height is still x. This angle is 51.8 degrees. What would this entire bottom piece be?
Y plus 35.
35 plus y or y plus 35, either way. Okay. So, do we have enough information in either triangle to solve for everything? No. So we're going to use each of them. In that red triangle, x is opposite, y is adjacent, so I could say tangent of 74.2 degrees equals the opposite side x over the adjacent y. If I want to solve for x, I could multiply my y over. Let me get this. Looking at the black triangle, we could do the same thing. We could say the tangent of 51.8 degrees equals the opposite, which is x, over the adjacent y plus 35. Okay, we want to get rid of the fraction, so if you multiply that over, you'd have to distribute, so you get y tangent of 51.8 plus 35 tangent of 51.8 degrees equals x. I apologize, I know I didn't leave you a ton of space on that handout. What would I do at this point? They're each equal to x, so you can set those equal to each other. I'm trying to solve for y, so I need to put both of those on the same side. I'll subtract over this one. Now what can we do?
Solve for 35
Well, we have to get the y by itself. We can't actually subtract those tangents, but we could take out a y. Okay. Then y is multiplied with that, so we could divide it all over. Again, we're not putting anything in the calculator until the very end, which is why this looks so ugly right now. When you type it in your calculator, every time you push tangent, it opens a parentheses, so make sure you close it. Make sure you have parentheses around the numerator and the denominator. Make sure you are in degree mode. So everybody, let's try to find this. Okay. We found y now. The directions said to find the height of the building. If I'm looking at my picture, the height of my building wasn't y, it was x. We can find it just by using one of these equations. I prefer the nicer one. X is just y times the tangent of 74.2. So take the y you just got, the 19.6527, times the tangent of 74.2. How many significant digits did I give you in the problem? I gave you 3 on the angles, but the side I really only gave you 2 for the 35. So let's just round this to 2 significant digits. I get my x to be 69.45. So if you round to 2 significant digits, that would be 69. That one was kind of ugly, a lot of work. I won't give you too many of those. But are there any questions on it? I think we have like maybe 3 others that I skipped yesterday.
Yeah.
Okay, let's look at this one. The 2 equal sides of an isosceles triangle. So isosceles triangle with 2 sides the same. Each of those is 24. If the 2 equal angles, where are the equal angles at? The bottom. Find the length of the base and the altitude. To use our trig functions, we have to have a right triangle. Is this one a right triangle?
No.
How could I get a right triangle? What is altitude? Yeah. The altitude would be this side right here. We'll call that A. It forms a right angle with the bottom. So to find my altitude, I really just created a right triangle. So what trig function could we use? This is, from my 52, that side is opposite. 24 is hypotenuse, so we do sine. So sine of 52 degrees equals the opposite side A over the hypotenuse 24. Multiply that 24 over. We get 18.9123, but if I want significant digits, that's just two significant digits. So we say 19 centimeters. Okay, that was one of the questions. The base is this entire thing. But what we could do is find the base in this little triangle and then do what with it? Multiply it by 2 to get the whole thing. So if I want my B, that's adjacent, 24 is hypotenuse, so we could do cosine of 52 equals adjacent B over hypotenuse 24. To find my total base, you have to take that times 2, and we only want two significant digits. So if you take this times 2, you get like 29.55. So what would I use for my base? 30 centimeters. That one wasn't too bad, was it? A little bit better than the last one. The next two are ones that I think you can try on your own. So I want you to take a few minutes, try to set these up and solve them. Let's get as far as you can. So you've got the floor, it makes an angle of 33 with the floor. The escalator would be this hypotenuse. The vertical distance was 21, so we have a right triangle. Opposite and hypotenuse would be sine. So the sine of 33 degrees equals the opposite, 21, over hypotenuse, x. If you multiply over your variable, then to get x by itself you have to divide. So 21 divided by the sine of 33 degrees. If I want significant digits, I gave you 2 in the problem, so you would say 39 feet. Is that okay with everyone?
The one thing I got confused about is how long should it be? So after second guessing myself, I thought I was talking about the bottom.
Oh, I meant how long is the escalator itself, not the horizontal distance.
I put both answers just in case, but I got confused about that last time.
Could have been a little more clear with that question. But good strategy, when in doubt, find all the sides and test them. Okay, so now we have a man climbing up a pyramid. So here's my pyramid. He climbs 213 meters up the side. So he's standing up at the top now. The angle of depression. If you're finding an angle of elevation or depression, what do you always have to have? A horizontal. So he's up here, so I need a horizontal where he's at. The angle of depression, so from this going down, is 52.6. How high off the ground is he? So we could set this up a couple different ways. Probably the easiest, you want to find his vertical height, right? You could drop a perpendicular here. If I do that, I'll have to find one of the angles inside the triangle. Not that that's hard to do. How would I find this angle up here?
Take 90 minus 52.6.
Yeah, 90 minus 52.6. You could also just draw your triangle like this, couldn't you? That would also give us our vertical height, and then we already have the angle in the triangle. So either way, we want how high, so I'm looking for this side here. So if I set it up like this, that would be opposite and hypotenuse. So the sine of 52.6 degrees equals x over 213.
I'm gonna keep ours easy.
Multiply over the 213. How many significant digits?
3.
So to 3 significant digits, it would be 169 meters. What I want to do for the rest of the hour is just give you time to work. So yesterday, I gave you all the homework. It was a total of 8 questions. I told you to try about 4 of them last night, so if you got stuck on any of those, ask about that first. But ask anything that you need. You've got the